Hi, in this video we are going to solve this question to find the total resistance between the positive and negative terminals of the battery in the figure below. Alright, now when you look at this circuit, the important thing to always analyze is the components that are series and those that are parallel. Alright, so let's look at this. When current flows out of Vs, it flows through R1. At this junction here, junction A, it splits. Alright, so we say that these two branches are parallel, and at the same time at this junction here, okay, it splits again. So again we say that R4 and R5 are parallel. Alright, so from the top branch from A, if you look at the top branch from A, we can say that the current that flows through R2 is the same current that flows through R3. Okay, so since the same current flows through these two components, we can say that R2 and R3 are series. Okay, so series means the total resistance will be 47 plus 47, which will be equals to 94 ohms. Okay, for that top branch. Now at the bottom branch, okay, we have another split between that goes into R4 and R5. Alright, and since the current splits into both these resistors, we say that they are both parallel. Okay, so we say R4 is parallel to 68 is parallel to 39. Alright, so you can solve for that and you'll get 24.79. Alright, so to find the equivalent resistance for parallel circuits, alright, we can use the formula 1 over RT is equals to 1 over R1 plus 1 over R2. Alright, you can use that. Or for two resistors in parallel, you can just say RT is R1 times R2 over R1 plus R2. Alright, so using either formula, you can find the equivalent resistance. Alright, so let's redraw the circuit. Alright, step by step, okay, as we analyze, so that it's easier to keep track. So with this first level of understanding, okay, I'm going to redraw my circuit. So this is Vs, this is your 100 ohm, your R1, okay, and from this point here we branch off. So we have already calculated that R2 and R3 are series, which will give me 94. And at the bottom, R4 and R5 are parallel, and that will give me 24.79. And following that, we have another resistor R6, which is 75. And both of them will combine and then go to ground. Alright, so again, let's analyze. The current that flows to 100 will split here into the top branch and bottom branch. For the top branch, you only have a single resistor, 94. For the bottom branch, you have two resistors. Okay, and the current that flows through 24.79 is the same current that is going to flow through the 75 ohm resistor. So we say that they are both in series. Okay, so for series, you just add them up to find the total resistance. Alright, so this will be 24.79 plus 75, which will be 99.79. Okay, so I can go ahead to redraw again the next iteration of the circuit. Okay, so for circuit analysis, it's always good to learn how to redraw so that you can see the simplification, alright, stage by stage. So we still have 94 on top, okay, and at the bottom we have 99.79. Alright, and then over here again, let's analyze. The current that comes out of Vs flows to 100 ohms, and at this point it will split into the top branch and bottom branch. So we say that they are both parallel. Correct, so we say that they are both parallel, and so the equivalent resistance, okay, would be 48.4. Again, you can use this technique over here to find the equivalent resistance for resistors in parallel. Okay, so I can redraw it one more time. Alright, so I have Vs over here. Alright, 100, and the next resistor is 48.4. Alright, and since 148.4 are in series, okay, they are in series, so the total resistance is just adding up. Okay, so the final simplified circuit will look like this: Vs with a single resistor of 148.4 ohm. Okay, so the total resistance RT is given as 148.4 ohms. Okay, so I hope it is clear how you can analyze the circuit, okay, step by step. Alright, from what is series, what is parallel, and then you redraw until you achieve the final simplified circuit over here. Alright, thank you for watching, and I'll see you in my next video. Bye.